our last form that we're going to be looking at here, which is intercept form. Okay, so we've had 3 different forms now we've looked at in terms of the equations. So I'll do a quick review of that. Why not? Yeah, I think we did skip number 7. All right, so we start off with vertex form. So that's y equals a times x minus h squared plus k. And in vertex form, it was really easy to see the vertex, correct? So we know that x lies and y tells the truth, and so we can really just look at it and see the vertex, okay? Then we went on to standard form, ax squared plus bx plus c. On this one, we had to do a little formula to figure out the vertex. It was negative b over 2a, and then plug it in to find y. On this one, it was really easy to find the y-intercept. It was just c, okay? Okay, lastly here, our last form is called intercept form. And that one is y equals x minus p times x minus q. X minus p times x minus q. Both of them in parentheses, okay? This one you can also call, and you can call this factored form. You may notice here that kind of looks like if we put some numbers in there, especially like our first one here, like x plus 1 times x minus 3, that looks like something like what happens after we factor. After we factor, do that x thing, we get 2 parentheses just like that. Okay, now intercept form, it's actually really easy to see the x-intercepts, okay? So vertex form, it's really easy to see the vertex. Intercept form, it's really easy to see the y-intercepts. It's just going to be x equals p and x equals q. Those are going to be the x-intercepts, okay? So kind of like vertex form, x lies. So on this one, both of my x's are going to lie. Okay, next up we'll find the vertex. So to find the vertex, it's going to be x equals p plus q divided by 2. P plus q divided by 2. And what that really is, it's really the average. You guys know average, so you add it up and divide by the number of numbers. So we take our 2 x-intercepts and we take the average. I did not write that very nicely. Let me try that again. Average. That's better. All right. And then we're going to take that x value and plug in to find y. All right, we know our line of symmetry is always the x value of the vertex. So I'm just going to write that. And now, lastly, the y-intercept is not going to be easy to find anymore. We have to plug in 0 for x. All right, fun stuff. So let's check out this one right here. Okay, so let's find our x-intercepts first, since that's the easiest thing to find on this one. So we're almost always going to have 2 here. And so it is going to be at -1 and +3. So I take the 2 numbers in the parentheses, and I switch them. X lies, okay? So we can draw those x-intercepts right on the graph. All right, now to find the vertex, I take those 2 x-intercepts, add them up, and divide by 2. It's, once again, I'm just taking the average, okay? The other way you can kind of look at this is look on the graph, like right in between the 2 x-intercepts. What's the x value right in between those 2 x-intercepts? I would say 1 is the x value that's right in the middle. So that's kind of also the definition of average, is like the number that's in between those 2 numbers. So if you want to look at it like that on the graph, like what's in between these 2 x-intercepts, that's your x value. Now I still need my y value, so I have to take that 1, and I have to plug it into the function. So I'm going to plug it in for x right there, and plug it in for x right there. So I went to the x plus 1 times x minus 3 function. I plugged in 1. Now I'm going to do my PEMDAS. All right, so my vertex is going to be at 1, -4. I think you can already see the shape of that graph now. We have our vertex, and the x-intercepts is already going to make that nice U-shaped parabola that we like. Sounds good. We know our line of symmetry. It's going to be x equals 1. I see that the vertex is the lowest point, so that's going to be a minimum value. And so the lowest y value on the graph is -4. So those are the other 2 pieces of information that we always get from the vertex. And then lastly, we'll find our y-intercept. So I plug in 0 for x. And I'll do my PEMDAS there. So I got a y-intercept at -3. If you look at my graph, I kind of already drew it, and to me it looks like it went through the y-axis at -3 anyway. So I'd say I drew that good. All right. I'm going to move on to number 8 in 30 seconds here, but I'll give you 30 seconds to get caught up if you're not. But if you're all done and you want to take a look at number 8 down there, feel free to get started. All right. So number 8, I'm going to start off here with my x-intercepts. So those are going to be at -5 and -3. Now I see a negative in front of these parentheses, so that kind of tells me that this is going to be a downward facing parabola, but I think we'll figure it out anyway. So let's find the vertex next. So I'll add those x-intercepts up and divide by 2. I get -4. I also see once again that that's the x value that's right in between my two x-intercepts. So that's also a good confirmation there. All right, I have to plug that into the equation to find y. Now we got to be careful here because we have that negative out front, so I need to make sure I include that. All right. You should really think of that negative out front. It's like a -1 that's multiplying. So this is -1 out front times 1 times -1. So -1 times 1 is -1. -1 times 1 is actually +1. So my vertex is going to be -4, comma, +1. It actually makes sense that the vertex is up there because that makes it open down, upside down parabola. All right, so now we know our line of symmetry. Is that x equals -4. I can see that our vertex is a maximum value. It's the highest point on the graph at y equals 1. And then lastly, my y-intercept. I have to plug in a 0 for x, for all the x's. But once again, I'm going to include that -1 out front. So -1 times 5 is -5. And then -5 times 3 is -15. We can't really see this one hitting the y-axis, but you can kind of imagine that if it continued down, it would probably hit it at about y equals -15. All right, last up here, number 9. This one's kind of weird. We have x minus 3 squared. Now, we talked about that this one is really x minus 3 times x minus 3. You could also think of it like that. Because remember, squared just means this thing times itself, right? So, where is our x-intercepts on this one? Well, there's actually only one x-intercept. It's at 3. It's right here. Now, where is the vertex? Well, if there's only, this one's kind of weird. If I think of it like there's 2 x-intercepts at 3, we could do it like 3 plus 3 over 2. So it's at 3. If I plug in 3, we see it's at 0. So the vertex is at 3, 0. So in this case, the x-intercept is actually the vertex. Now this one doesn't have a negative out front, so I actually know that it opens up. So this is an example where this only has one x-intercept. If we found the y-intercept, it would be 0 minus 3 squared, negative 3 squared, which is positive 9. So that's kind of further confirmation that it opens up, because you can imagine, once again, I can't really see where it's hitting the y-axis, but it would hit up there at positive 9. All right, last things, we have our line of symmetry. Is that x equals 3. And then our minimum value, since it's opening up, it's a min value at 0.